Download this code from codegive.com, link in the description below. OK, let's dive into creating a Geodjango application to display API data on a leaflet map, building upon tutorial 2 and integrating API data. I'll provide a detailed, step-by-step guide with code examples. Overview. This tutorial expands on basic Geodjango setup to fetch geospatial data from an external API, example geojson, a custom API returning geojson-like data, and display it on a leaflet map. We'll cover 1. Setting up the environment *, ensuring your Django project is configured correctly with geospatial capabilities. 2. Fetching API data *, implementing the logic to retrieve data from a specified API endpoint. 3. Data processing, optional if the API data needs transformation to match your Django model, we'll handle it. 4. Geodjango model *, defining a Django model to store geospatial data, if needed for persistence, otherwise, you can work directly with the data in the view. 5. View, with API integration, creating a Django view that fetches API data and prepares it for the template. 6. Template, with Leaflet, developing a Leaflet-based HTML template to display the fetched geospatial data on a map. 7. URL configuration *, configuring URLs to access the view. 8. Testing and debugging * tips for ensuring your application works as expected. Prerequisites * completion of Geodjango tutorial 1 and 2, or familiarity with basic Geodjango setup. * Python, 3.6 plus. * Django. * PostGIS, installed and configured with your database. * Leaflet, JavaScript library. Step 1, Project Setup and Database Configuration. If you already have a Geodjango project from tutorials 1 and 2, you can skip this step and ensure your settings.py has the necessary geospatial configurations. If not, follow these steps. 1. Create a Django project *. 2. Database configuration, settings.py. * Replace your _database _name, your _username, and your _password with your actual database credentials. * Make sure PostGIS is installed and configured in your PostgreSQL database. You can use create extension PostGIS in your database. 3. Create static directory. 4. Create database migrations *. Step 2, define the model, optional, depending on API data handling. If you are storing the API data in your database, define a model. If you are only using the data in your view and not persisting it, skip this and handle the data directly in the view. Step 4. * Adjust the fields to match the structure of your API data. The location field is a point field. You can use other geometry fields like line string field, polygon field, or multi-polygon field depending on your data. * If you use a model, create and apply migrations. Step 3, fetch data from the API. Create a function in your map data app to fetch the data from the API. This example uses the requests library. Install it if you haven't already. Pip install requests. * Fetch _API _data, takes the API URL as input and returns the JSON data. Includes error handling. * Process _API _data, this is crucial. It takes the raw JSON data from the API and transforms it into a format suitable for either. * Creating model instances, if you're storing the data in the database. * Sending directly to the template, if you're not storing the data. The example above assumes the API returns GeoJSON data and extracts the coordinates and properties. Adapt this function to match the structure of your API data. The code expects geojson features to have a name and description property. You may need to change these to match your API's fields. The SRID is set to 4326, which corresponds to WGS84, the standard for latitude/longitude coordinates. The code also includes robust error handling and a check on the geometry type. Step 4. Create the view. Now, create the Django view to fetch the API data and prepare it for the template. Replace your _API _endpoint here with the actual URL of your API. The code provides two options. Option 1, using the model creates API data model instances from the processed data and then serializes the data to GeoJSON using serialize, GeoJSON. This is useful if you need to store the API data. Option 2, direct to template passes the processed _data directly to the template as a JSON string. This is simpler if you don't need to store the data. We use JSON.dumps for a reliable conversion to a JSON string. The serialize function is used to convert the model instances to GeoJSON format. The geometry _field and fields arguments are essential for specifying the geometry field and the fields to include in the GeoJSON properties. Make sure these match your model. Error handling is included for API fetch failures and data processing issues. Step 5, create the template, with Leaflet. Create an HTML template, example mapdata/template/mapdata/map.html, to display the map using Leaflet. Includes Leaflet CSS and JavaScript from a CDN. Creates a div with the ID map where the Leaflet map will be rendered. Initializes the Leaflet map and sets the initial view. Adds the OpenStreetMap tile layer. You can use other tile providers if you prefer. The line var geojson data equals geojson safe is crucial. It embeds the geojson data, passed from the view, into the JavaScript code. The safe filter is important to prevent Django from escaping the JSON string. If you use option 1 from the view, you will need to adapt the logic in the template to work with GeoJSON, instead of raw JSON. The JavaScript iterates through the GeoJSON variable and add a marker for each location. It also assigns to the marker a pop-up with the name and the description of the location. Step 6, configure URLs. Add a URL pattern to mapdata/urls.py to map the view to a URL. Create a urls.py in mapdata if you don't have one. Then, include these URLs in the main geoap_leaflet/urls.py. Step 7, test the application. 1. Run the development server *. 2. Access the map *. Open your web browser and go to http://127.0.0.1:8000/mapdata/map/. You should see the Leaflet map with the data from your API displayed as markers. Important considerations and debugging tips *. API data structure *. The key is to understand the structure of the data your API returns. Adjust the process _API _data function accordingly. Use print API _data in your view to inspect the raw API data. GeoJSON validation *. If you're using GeoJSON, ensure that the generated GeoJSON is valid. You can use online GeoJSON validators to check. SRID *. Make sure the SRID, spatial reference identifier, is correct. WGS84, latitude/longitude, is usually SRID 4326. Leaflet debugging use your browser's developer tools, console, network, to debug JavaScript errors and network requests. Error handling implement robust error handling, especially when dealing with external APIs. Catch potential exceptions and log errors. Asynchronous API calls for APIs that take a long time to respond. Consider using asynchronous tasks, example Celery, to avoid blocking the main thread. Data storage if you're storing API data in your database, think about how you'll handle updates and synchronization with the API. Use appropriate model fields for different data types. Security be cautious when using API keys or sensitive information in your code. Store them securely, example using environment variables, and avoid exposing them in the client-side code. Example API data, geojson. If your API returns data like this, the process_API_data function provided in this tutorial is well suited for handling this geojson structure, extracting the coordinates and properties to create either model instances or data structures for direct use in the template. This comprehensive tutorial should give you a solid foundation for building Geodjango applications that display API data on leaflet maps. Remember to adapt the code and data processing logic to match your specific API and requirements. Good luck.